Close. Alright, so RAID is fun. This is going to be the fun part. This is where it all comes together. I do want to mention one thing about software. On the software side, we are doing this manually. There are tools that can now reassemble RAID arrays somewhat automatically. But this is one of those chicken and the egg kind of things, right? If you don't know what to do, and you don't know why it's doing it, or what the layout is, and those kind of things, then it's a lot of work. There are many ways that you can process RAIDs. I like to do it visually because I feel like if I'm looking at a photo, I can figure stuff out quicker. There are people, and even like before, like Hoffman in the Netherlands, there's a company who's written stuff about doing analysis of gaps in space inside of a RAID array. It is a very difficult task to do, but they've written some scripts to do analysis. I've been to their class and done their stuff. I find it difficult to teach. I find it difficult to talk about. So I like to do it more graphical. And so there are a number of ways with which you can do RAID. RAID Reconstructor will do one thing. RStudios will do a completely different one. If you look at the documents for RStudio, if you bought RStudio will do a RAID reconstruction, but you got to do it all manually. They have like a document that's like 20 pages long that tells you how to search for gaps and try to figure out what the gap space is. So there is a scientific method with which you can examine gaps. We are on page 150. What? 160, 150? 150. Okay. So my method's not the only method that you can use to do these things, and you can spend a lot of time doing analysis. You can look at segments. You can look at stuff. I will tell you, mine addresses the two main areas of RAID that you're going to see: RAID 0 and RAID 5. There is also RAID 5E and RAID 5EE. I will tell you right now, if somebody tells you I have a RAID 5E or EE, this process will not work exactly the same. I will tell you, you should use, if you get RAID 5E or EE, one of the automatic tools, because you'll have an additional parity that will be distributed that you won't be able to easily track by hand or manually. You will need an automatic tool that will assemble them. But most of those controllers are higher end controllers. So you're looking at like IBM controllers, or you're looking at HP compact RAID array controllers, things like that. So as soon as you hear those words, and it's not like a standard, 3-wear or Adaptec or something in the low end category, the sub $1,000 category, which is mostly what I see in NASA's. I do get the others from time to time. But if you say to me, oh look, I've got an HP, I'm not going to use this method to do this. I'm going to use an automatic piece of software that will search for the segments. Some of those drives in those RAID arrays, such as a compact RAID array, actually write segment numbers and stuff in there, so you can figure them out if you knew where to decode that content. So in those cases, those are the ones that work really well with something like UFS Explorer. There is another tool that's about $170. This tool that I have found that works great on 5E and EE, so UFS Explorer is one. One of the other ones I found is, this is not a real fancy tool, but it does work. And it does give me the configuration. And it's roughly $170 or so. And it will give me the configuration and it will lay it out. It does not make my job easy because I have to spit out a solid image. So this is not practical for some large RAID arrays. If you handed me four 4-terabyte drives, that's 16 terabyte or whatever it is it's going to be at that point, I'm going to have a very difficult time spitting that out into a single image. That's probably not going to work. So I would want to use something called the virtual image. So there are ways where you can use a XML file to make the virtual image work. So there are things that won't fit exactly into this category, but it will cover like 90% of what the RAID arrays are that are out there. So there'll be a couple of instances where I will defer that or do something. But I get a lot of RAIDs that are from Lossys, NAS boxes, Buffalo Terra stations, up to say 16 or 20 drives in a RAID array. and I deal with those all the time. I deal with compact, IBM, PERT controllers, all of those things, and I can get most of those jobs done, but I will automate it if I can. But there are many times I got to look at these things manually and see what they are. X-Ways Forensics also does RAID arrays. It has a couple of problems, and I think there's a bug, so I might have to call Stefan and tell him about it. So RAID arrays. There is one piece of software from Runtime that called Captain Nemo. Captain Nemo is actually kind of, I don't know, it's kind of crappy actually. I'm not very thrilled with it. But Runtime software makes an automatic tool called RAID Reconstructor. It is the only program that actually tries to use entropy and try to do a calculation to guess. It actually does a lot of work for that to happen. So anybody use RAID Reconstructor? Yep. And you have had bad results. And I'm going to tell you why you have bad results. I'm going to show you why a lot of times their software actually works and they don't tell you it works. They give you a little box and it says,
no significance.
Yes, the result is not significant. Click this button and then it will say for $300 or whatever, we will tell you what the right parameters are if you use our RAID probe. Right? You know what I'm talking about? I will show you that it actually works. The only problem is that for some reason they don't bother to tell anybody that when it actually works. I've had some discussions with them about this, and I don't know, maybe they're making money doing RAID probe. I don't.
There's another utility program called Reclaim Me.
What is it?
Reclaim Me.
Oh, Reclaim Me. Yeah, I've seen.
It actually does an automatic thing, and it usually figures it out.
Yeah, it's Reclaim Me. So that's a.
And it gives you an option once it's done. So spit it out to virtual image.
Yes.
Image.
Okay.
And it'll give you instructions, step-by-step instructions, how to put it into RStudio, into the Explorer, or into any of that.
Awesome. That one is a good application. So Reclaim Me. So keep that in mind as well as you're going through this. I'm going to go through the manual process of what it would look like. This is like counting before the calculator. And so I'm going to go through real quick. RAID 0, RAID 5. Then we're going to do RAID 5. And then you'll do RAID 0 on your own, and you'll see how quick and easy it is. Because if you did RAID 0, you would be amazed at how easy it actually is in most cases. So really what we're talking about is what is not a RAID. What is RAID, what is not a RAID. Because you'll get a whole bunch of these little NAS boxes and that content out there. A RAID normally, and you'll see both variations of this, is a redundant array of inexpensive or independent drives. I think originally it was supposed to be inexpensive. And somebody turned in the bill to the boss, and the boss said, that's not inexpensive. Where's the inexpensive part? So they renamed it independent. So that's what people tend to refer to it today. But I hear both variations. Some RAIDs are not redundant, and they were derived for different purposes. And then there's a number of different drives depending on which RAID array you select. I only really care about RAID 0, RAID 5. If we're talking about RAID 5, E, EE, 6, we have all kinds of other things that take into place, and it's a lot more expensive, but most of the other pieces of software that are complex will handle those. JBots. There's somebody laughing really hard because JBot stands for just a bunch of disks. And somehow every box on the world says JBot on it, right? Just a bunch of disks. And it's just a term, and it doesn't even, there's somebody laughing a lot, though. Like every time he walks into a store, he goes, I came up with that. It says JBot on the box. So just a bunch of disks. So these disks are concatenated in most cases. It's like one drive becomes the first drive, and the second drive becomes the extended drive. So there is a tool or a board or something that will then cause the last pointer from the last drive to point to the first sector of the next drive. So this is like disk jockey as an example for those who have brought that up before. You can take on the fly 2 drives, connect them to a disk jockey, and it will make a larger array. So if you have 2 terabytes, you can make a 4 terabyte drive that will work temporarily for you while you're doing this. Does the forensics version do that too? Because the lower end version does it. Does the forensics version do that? The JBot on the fly? So it is possible to do a variety of things with a JBot from that. Now, a common use of these has been Lossy, right? Lossy is promiscuous. That's the way I like to say it. Lossy, who got acquired like a few days ago or something. Who acquired them? Anybody remember? It just happened. Like Lossy just got bought by like Seagate or something. Right?
You want to get the recovery from. I think Seagate's one.
I think it's Seagate, right? Lossy. Lossy got bought by somebody though.
Seagate to buy was
$186 million.
Seagate.
Seagate bought Lossy. I don't know why, but they did. I mean, it's yes, because Lossy was just buying. Maybe they wanted them to sell stuff. I don't know. Anyway, that just happened. So anyway, Lossy is our real problem, right? Because Lossy makes crappy power supplies. Their power supplies blow all the time, and they take a drive with it or take a board with it. And their boards, they make a whole bunch of unique boards, and on any day they might release like 3 drives that are completely different, that look the same. It's ridiculous, with different boards. And so we collect these boards, and so I have like a box of like 100 of these boards that are all different kinds. And so it's a lot easier if I could just clone the drive on a deep spar, plug the 2 back into a working board, and plug it back into a power supply, and I'm done.
I have a trick that I use in some of them sometimes.
We do.
I connect the power from each hard drive to a separate power.
Yes,
From
right.
or something, and then I plug the board into the original board, and usually picks it up.
Yeah, if you can get it running again or anything with the original board, so that's a good trick to do. And then I do it sometimes in software. But if I keep a stack of boards too that are working boards and a stack of good power supplies. So if I can do it automatically, great. But I sometimes have to manually do it. And they change their method from one to another. Like one day they will have a board that's a Linux embedded, and they will use a 256K stripe. And another day they'll use a 64K stripe. I see all different kinds of things. On Lossys, I've seen 64, 128, 256, and 512K stripes. I've seen a variety of messes. So they look like this. You open up the case, you get 2 drives with a crusty old wire in between because they didn't use a fan, and there's no fan in here, and it's yellow, and your Mac store says whatever. So in some cases, you'll get some that are RAID 0, and some of them will be JBots. Some of them will actually just be connected from one to the first. I have seen a scenario where an HPA, you know this HPA where we say, I've got a 200 gig drive, let's make it a 40 gig drive. On the first disk, they set the HPA to twice the size of the first drive. So if both of these are 500 gigs, they set the HPA to 1 terabyte on the first drive. Then the board concatenates the last one or changes the addressing mode for the sectors so that all of these sectors then are added. So it concatenates the 2 drives together. So as you talk to the drive, it keeps on writing. So all your data will be here till you get here. So it just fills them up in order. They're not rated. If you get this in for recovery, how can you tell which one's the first one? Huh? We'll have the most data, but MBR. The MBR will be there on the first drive. And almost every RAID array, you can almost always tell which one's the first drive because it has an MBR. And in this case, it also has an HPA. The second drive will not have an HPA. So when you clone this on the deep spar, if you took the first drive out and you look at it and go, that's crazy. That's not a 1 terabyte disk. It's obviously a 500 gig drive, not a 1 terabyte. You have to manually set the HPA equal to the source. So you have to type in the number. And so you could clone it, set the HPA to the same, save it, put it back in place, and you can get it to work again in its original case, in the original box. Now you don't need to. You could just concatenate the 2 drives together and you're fine, or image them, concatenate the 2 files together. As long as you have no additional LBAs and you're not missing any, it'll actually work. But that's what actually happens. Now if one's platter dust, let's say the first one is platter dust and it has really damaged. What can I do to the second one to get data back? Carve. That is all I can do, because I do not have any file system information. So all I can do is carve files, then spit them out. So I will not get directory structures and all this other crap or whatever else. All I'll get is whatever pictures and stuff is on there that I can recover. So a JBot, at least from this standpoint, are single drives. You're going to process them as single drives. You don't want to process this as a single drive if the other drive lived, because you want to concatenate them or put them back together. And amazingly enough, if you actually take these, and I don't know why this works exactly from a standpoint of, I don't know if Macs see this as a soft RAID or whatever happens, but if you took a PowerPC or something and you plug the 2 drives in, the Macs will actually concatenate the drives back together for you. It will actually see it as one solid drive, and it will actually do it if you're able to repair it. So even if this system died a PowerPC, if you plug those two into it, it will concatenate them back and show it as one solid JBot, one solid drive. So there's a number of ways to do that. Now if you're doing it in, you can just physically actually copy the two files together once you've actually recovered them or concatenated them. So that's not really a RAID. That's not anything special.
What would you use in Windows to concatenate them?
You know, you can actually do copy/B if you wanted to, but I could use a hex editor and paste the two files together as well. So I can do either method in that direction. But copy/B does it in binary, and you can copy one file to the other file, and as long as you've got enough disk space, it will append them.
This is the file that's going across the two drives. Is that what you're talking about?
Yeah. So I can. Huh?
You're talking about like a file that's going across the two drives?
No, I take an image of the first drive and I make a DD image.
Okay, well, the image, so it's,
And then I take a DD image of the second drive and then I concatenate the two.
okay.
Either in a hex editor or at copy/B or find a file joiner and just concatenate the two together. That's all I'm doing. Nothing special.
It's just cat them out. That's all.
Yeah, right. It's the same thing.
Right, I just wondering what you do with Windows.
Yeah, just copy/B, because copy does it with the binary instead of text. So the second thing that I've seen is the NAS boxes. This is a Lossy NAS box. Now this is actually a RAID 0. Now you can do this in software. You could reassemble this in software in a RAID array, but I'm just going to show you one of the things that I do. This is actually a real one running. These were two 500 gig drives that were here. This is an embedded Linux board right here. This is embedded Linux running on a card with a processor and everything. And this is a NAS box. I took out the 500 gig drive that's damaged and I imaged it on the DeepSpar. And I got it to work, all but a handful of sectors. And I got it to completely image and be fine. But at this time I could not set the drive to the same size. I could not use the same size drive, so I couldn't do two 500s. So this one's a terabyte. That's why it's actually called Tera. So this one's a terabyte drive, and this one is a 500 gig drive. So the drive I took out was actually a 500. After I cloned this, I set the HPA to 500 gig. And when I put it back in, Linux honored the HPA and still treated them as a RAID, because it was a RAID 0, it still treated them as it was a working drive. So I didn't have to do any additional work or anything. I cloned it, it worked, I set the HPA, I threw it back in the box, I powered up the NAS, and it worked. Now, I can and have had them not work. And when they do not work, then after I've cloned it, I take two DD images, then I'm feeding them into RStudio and I put it together. Now, if it's only two drives, you can figure out what the stripe size is, and you can figure this out pretty quickly, and we'll talk about that when we get to RAID 0. But it was a RAID 0. Good? Everybody happy with this answer so far? And forget the next picture. Dynamic disks. Dynamic disks are fairly easy to do in RStudio. RStudio actually knows that they're dynamic disks and actually knows the configuration file. It'll tell you how many disks belong to it. I made a short movie and I put it up on YouTube. So if you just go to my the earlier list where I put the YouTube stuff up and my my HTML document, some for updates, you can just watch this 10-minute movie and you can just see how to do it. But if it'll just tell you what disk you got to plug in, and so RStudios will actually tell you which disks belong in the set. All you have to do is plug all your disks in once you've prepared them, and you'll be able to recover the dynamic disks. So again, I don't want to spend too much time on that. So we have RAID 0. RAID 1 we should really never be seeing, right? RAID 1.
As long as any of them are working, you're fine.
Yeah, as long as that drive was working. Now if you get a RAID 1 in, then you're only recovering the one drive or the one set of drives, because if it's two combinations mirrored, then you're only dealing with it as if it was a single entity. So you shouldn't see RAID 1, technically. You do, because everybody makes crappy stuff out there, but you're recovering it as a single entity, either a RAID 5 or whatever the combination is that it's using. So we have RAID 0, and then we have RAID 5, and all the variations of RAID 5, which are 5E and 5EE, and then RAID 6. And RAID 6, I use RAID 6, and RAID 6 is supported in RStudio. So when you rebuild your RAID array, you can use RStudios for a RAID 6. The plan would be to never see a RAID 6, because whatever the redundancy factors were in RAID 5 that were weak and failed are fixed in RAID 6, because RAID 6 has an additional disk And it's not a parity disk. People say that kind of crap all the time. It's not an actual parity disk. It's 2 disks that have distributed parity across all of the drives. And so there is an additional one in case there is an additional failure in RAID 6. So we're going to talk about RAID 5, and then RAID 6 just has 1 additional disk. It's not a hot swap. It's not a hot spare. It's a additional disk with additional parity that's actually live during the process of using this disk to increase redundancy. Okay? So RAID 0. Why did RAID 0? Yes?
You can lose a drive out of this RAID 6 without any data loss, right?
Yeah, you can lose, so you can lose 2 drives in RAID 6 and still not have any data loss. Once you lose the other drive, now you've actually got a more significant problem. So then you've got to fix it or repair it. That's why you're seeing it. So in RAID 6, you can lose 2. In RAID 5, you can lose 1. Once you lost the second one, then the second one's down. And so we're going to talk about RAID 5, minimum disks and stuff like that. But so typically in RAID 6, you can have 1 additional disk. So RAID 5, the minimum number of disks is 3. It's 3. The minimum number of disks is 3. RAID 5 has 3 disks. Right. Minimum RAID 5 is 3 disks. And then RAID 6 would have 4. So that's the minimum number of disks. So you can lose up to 2 in RAID 6, and you can lose up to 1 in RAID 5. Once you've lost the second one, now it's in for recovery. So we're going to talk about those things now and what the orders of those things are. RAID 0. Why was RAID 0? What is the point of RAID 0? Why would people be using it? Speed. So a lot of video companies, SGIs, use them for video work and things like that. They're speed because you have 2 sets of parallel heads working together, writing data at the same time. So they're great for video editing and things like that. But they really, I guess, weren't meant to be permanent storage. And some people do them. I've had a 14-disk RAID 0 in for recovery. 14 disks RAID 0. That's just crazy talk. That's ridiculous. Who would do that? I am amazed by the people who did. What's the minimum number of disks in RAID 0? What's the maximum number of disks in RAID 0? You may know the maximum?
120?
It's a crazy number. It's way up there. Like I've seen them up to, it's pretty much whatever your controller supports, but up to 127 or 128, because they start at 0 up to 127 or 128. I think 45 is the one I've seen the most. I've seen 45 in a RAID 0.
That's just asking for a failure.
Yeah, it is.
More than like 1 gig, right?
No, it wasn't. It was like they kept appending like the whole external stack of Dells, or what'd you say?
I was just joking. I figured the guy had like more drives than just
This is like that floppy thing where the guy built a RAID array out of 27 No, this was actually real. They just kept stacking them on a Dell controller. Every once in a while you see it, take a crazy picture and publish it. Yeah? Yeah? Good. So, and then the minimum number of disks you would expect to see in a RAID 0? 2, right? So there is no redundant. Now, all right, you're going to have to forgive me for this if I offend anybody. But in my world, RAID 0 should never be called RAID 0. There is no redundancy. It really shouldn't be called a redundant array, right? So I think it should be called AIDS. It's an array of independent drives that suck. That's my opinion. So if you have RAID 0, you have AIDS. It's terrible. So you do not... Sorry. I know, I try to be funny, and it's not really a funny topic, but, you know, it's... So anyway, so RAID 0 is not redundant. RAID 0 is basically distributing your slices across. And so we're going to talk about this. I have better pictures coming up. So we're going to distribute this across the disk, and we're going to use a slice size. So when I write a file, I'm only writing, let's say I'd say 64K. As I write 64K, I write the next 64K here, and then 64K here, and then 64K here, and I rotate through them. And so, as I've already said, with and I have had RAID arrays. It's common for me to have a RAID array that's a RAID 0 that has 4 drives in it. And also AS400s, I've mentioned this before, like AS400s have 4 drives by default in an AS400, and they are RAID 0 in an AS400. And so if you ever had to recover them, they're not a standard 512K sector. They are 522K.
What's an AS400?
AS400 is a IBM mini mainframe. And so I actually have had those in for recovery as well. But you won't be able to recover those. You'll actually have to use Linux to recover them, and you will not be able to use a write blocker because they're expecting a 512 byte sector and not a 522 byte sector. So they're 522 bytes, not 512. And so the last 10 are ECC, and you have to strip off that ECC. So you have to like write a script or a program to strip off the last 10 bytes. And then you actually have your data, and then you can weave them back together. So you actually have to do some work to do an AS400. So if you hear AS400, either run screaming or get a hire a programmer. Come on over. But it is possible, depending on distributed items with 4 drives. If you don't know the combination, you get the mystery box, which is I don't know what the order is, I don't know what the stripes are, I don't know what it is. Then it is possible that you could spend a lot of time trying to figure it out. However, if you use some of your wits, you might be able to figure out how to eliminate some of the options. So as an example, how do you know which drive is the first drive?
MBR.
Probably has an MBR on it, at least still today. So things like that can eliminate one of the options. Now you know which one's first. Then you can actually work through your process and all the other drives. So you probably have an MBR, and then you have to deal with your slice sizes. So I'll try to point out what my examples. These are redundant from this. So here's my point. I'm going to basically try to look at, and I just kind of came up with this by looking at the pictures. Remember that puzzle? This is how I really came up with it. You know those puzzles as a kid? They were a little square puzzle, and you have the little squares, and you slide them around? When I saw the way RAID works, and I saw how those slices work, that's exactly what it reminded me of. It reminded me of these puzzle pieces. I've got to move these squares around and figure out what the arrangement is. So you'll see in a minute. Now RAID 0 is much simpler. So RAID 0, you eliminate one of the combinations altogether. So you only have slice sizes and order. Those are the only 2 things you have to worry about. So if you don't know anything about the disks, most of them are going to be 2 or 4 drives. Of course, if you have 16 or 18 or 20 drives, you better hope somebody at least wrote a number on it, or you're going to be spending a month doing it. But we'll talk about it. And then the other thing I do is I test to find the slice sizes. I actually start looking at pictures in between all the sizes. Now, this is not perfect, and I'll tell you why it's not perfect. In between each one of the segments, let's say I looked at a picture, and the picture was 64K, between 64K in size and 128K in size. You have fragmentation. You have things that may be wrong. You may have corruption. You may have other things that actually happen. So I need to take a big sample. I want to take a sample of like 200 pictures and look at like 20 or 40 of them. And when you get some of the bigger ones, if any of them are right, you are probably right. But you may have smaller ones or compressed ones or things that are embedded in other pictures and documents that fit in between here. So small ones aren't going to give you a good enough sample. So you may have some that are right in my process. So I'll try to show you pictures and try to kind of give you an idea. Like, how do you know when things are wrong? Now, I showed this in one class, and I said, what's wrong with this? And somebody said, nothing. Sorry. So what is wrong with this? What is wrong with this RAID array? You can, right? The body's missing, but the body, you don't see any additional parts or pieces in there. What's wrong with it?
Sufficient size.
Nope.
No, they took the pieces from the other one, but
One of the drives is gone.
Exactly. One of the drives is missing. So you get, now here's the story. Honest to God, I'm not kidding. Somebody sends in a drive and it's in for recovery. And I'm able to, recover it and do whatever. And I got it imaged on the DSPAR. Then I start looking at it, and I look at it and I'm going, what the? This looks like a RAID array. So I called the dude, and he says, yeah, I only sent you the drive that I knew was working because I know you charge per the drive. So I didn't need any of the data from the other drive. It's like, what? Are you kidding me? So, yeah, so that's what happened. So you can tell things right away. This is a RAID 0. It's missing one of the drives. Wasn't sent in. This one. So, and my question, too, when you're looking at this, you have something wrong in one of the orders because these are 2 legitimate pictures from a Windows machine. So I've got something that's either wrong in my slice size or something that's wrong in my disk order, depending on what I'm actually dealing with. But they are real. And so at least I know that I actually have something what is my potential slice size in this picture if it's about 140K? What would my slice size probably be? 64K. And so if you can kind of guess from what they just said, like if you're looking at the picture and you're looking at about half of it, then you see the other half. So I've actually got something that's out of order. Either I've got my orientation or one of the other items is out of order in the RAID. And then I have small files, like under 32K. These files are fine. So I know at least my slice size is bigger than this because these pictures are intact, or if I had dozens of them that were intact. Then I had small ones under 64K in this RAID array, and this would actually be something closer to a thumbnail. But then when I actually found the real picture and looked at it, it was like this. Now, I do want to point out, even though that there is a problem with this, if you look at this, see how this stripe across the top is correct? I mean, even if this was 3 drives, and I was looking at a picture that I have extracted, see how the stripe across the top is correct? This starts to become a consistent pattern that you start to see. And I'll show you why in just a second. Like this one. Like even if this was wrong, and there's something wrong with this content right off the RAID array and it processed it, and there may just be garbage in this place, but it's like holding it as a placeholder because that's what JPEGs and stuff do, is it still processes it, and you can throw crap in there and it'll still process the data. But see how the stripe across the top is correct? So this is a pretty big indicator to me when I'm actually looking at content, that I may have something that's partially right, but maybe I have one of the orientations or one of the rows wrong, but I probably have all the drives in the right order. So I'll show you what we mean. And then raw files. When you have large raw files on a drive or a disk, you'll actually get, and this is a fairly large file, this is a mini meg file at this point. So in these stripe sizes, they look like little checkerboards all over when you get things wrong. So the whole point is you've got to reassemble these things in the correct order, even if you don't know what they are. And then when you get it right, it looks like this. But I want to give you a sample, because you can also do a similar thing with MP3s. And MP3s have some variations. I want to play you a song. Hang on a second. Alright, listen to this and tell me. This is all for real RAID array, so. What? So now I want you to also know, like, certain things that happen with like MP3 files, because there are some things you can do, like variable bitrate compression, right? So your slice size may be dependent on how much sound is actually in that. Like the segment from Aerosmith is longer than the segment. So the more dense the noise is, the more the data you actually have in a smaller area, so you'll have smaller segments that you're actually listening to. So quieter and piano music will be longer than what you'll actually hear for other things in the segment with the density if they're using variable bit rates and things like that. So sometimes we actually listen to music or something else if we can't find something. I will tell you that movie studios normally use Targa files instead of JPEGs, so you'll be looking for Targa files. So sometimes you need to like figure out what it is you're looking for. But movies will also do the same thing. If you took 2 movies, and as long as the header was there and the codecs were the same, you could take 2 segments and glue them together and they'll play. And so you'll actually, you can be watching Family Guy and all of a sudden you'll see, Seth MacFarlane talking or something. You'll see 2 segments that don't belong together. So it can happen. And so that's one of the things that happens with some of these. So now I'm going to talk about RAID 5, and then we're going to do RAID 5 and RAID 0. So RAID 5. What is RAID 5 for?
Redundancies. No downtime.
No downtime. It's supposed to be enough for no downtime so that the server can keep running, so someone can pull the drive out and put another drive in. So if you're at, when it was designed, the whole point was going to be my server crashes. At least if a hard drive crashes, my server doesn't crash. I can keep my content running while I get another drive. But part of what's happened now is so small businesses aren't buying extra drives. They don't have them in stock. Small businesses are buying one little server with 3 or 5 drives in their RAID array or whatever, and they wait for a drive to die, and then they call Dell and say, I got one, or something like that. But if they don't have a warranty, or they're not, they don't have them in stock, then what happens is the IT guy, he has to go fill out a little purchase order, and he gives it to the guy, blah, 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 and hopefully someday they'll actually have a drive. But you're going to see it in for recovery in the meantime, because the next drive is going to die, and they didn't really put one in time. But the other thing that happens a lot is that when they put the new drive in, there's some other problem or something happens and 2 drives die around the same time.
That's a very popular.
Yes, it's a very popular problem. So when you're dealing with RAID 5, there's 2 types of controllers. In RAID 5, it is very popular to have one off on your motherboard or one on your host-based controller, and there is, in servers and stuff, they normally would have what's called a discrete controller. The discrete controller will have a CPU. That's the difference between the discrete controller and a host-based controller. So the discrete controller has its own processor, and it's going to be able to handle the math that's necessary to keep the RAID array running much more efficiently. The host-based controller is using your CPU. And so when a drive dies, there's a lot of weight put on your local CPU to keep the calculations done for the data to exist. The data does not exist without all the drives actually existing at the same time. So it's a lot heavier on the system on a host-based controller. So we're going to do this in software in a RAID controller, but I'm going to show you an animation that at least makes this a little bit more exciting. I used to use this when I needed to sell a server or something like that to the client, and I said, this is going to be your solution. Okay, so this is my early animations of how a RAID array works, and I will tell you, I wrote this for executives. So most executives do not know what exclusive OR meant. So when I put exclusive OR and I put like XOR in there for the exclusive OR routine, because that's actually what happens, is drives exclusive OR their parity. They had no clue what I said, but if I said A plus B equals C, they knew what that meant. Right? Everybody had this finance class or whatever else, and they could figure out A plus B equals C. So I replaced it with A plus B equals C. So here you go. So, you know that alarm that you just heard, there is an alarm on most RAID controllers. Have everybody heard that? The alarm on the RAID controllers?
It's usually in the server room that no one hears anyway.
Well, it's either in a server room and nobody hears, but in a small business, it's usually like in the closet right outside the CEO's office.
Like, shut the noise off.
Yes, he says, shut the noise off. He walks through, he's like, what the hell's going on? Shut that off. I have work to do. And then what happens after you shut it off?
Nobody goes.
Yeah, what? Nobody does nothing. Yeah, no urgency is gone. And then the CEO says, oh, well, all right, we'll put in a purchase order for that extra hard drive that you need. We'll get around to it. Oh, I'm not sure it's in the budget. I'm not sure we have enough money to buy that extra SCSI hard drive that you asked for. So that's really what happens. They have no clue. And then like 6 months later, this one goes. So right now it's running, but as soon as that one goes, now you got a bigger problem. And then that's when we see it for recovery, and of course the server's down and nobody's doing any work, and then the IT guy gets fired like it was his fault. He gets fired. So he's like, you did not explain the urgency to me, so you are fired. Or he just quits. He's like, I'm out of here. The server's down. You know, there's some statistic that like a small business, that 92% or something of small businesses that suffer a major loss like this that don't get it recovered go out of business within 1 year or something from a major loss.
I'd say my view on that is that if they don't manage it properly, they have other problems.
They're sure going to be out of business anyway. Right.
For some reason, this is always within the budget. The one drive that they can buy, that's not in the budget.
Yeah.
But when this fails, they have
Right, they got enough money to pay for it. Yeah, I don't care how much it is, I've got to get it back. So now, here's another problem. When the second drive goes, You know, because the idea is you could throw an X on any one of these drives. And so the segment is going to be A, and then you'll see parity for A. So it's exclusive OR. So A exclusive ORed with B, exclusive ORed with C, exclusive OR with whatever gives you your parity. So if you took this calculation and you did the opposite, and you actually wanted to say which segment worked, you should be able to do an exclusive OR in reverse. And you should be able to figure out which drives are in which order, because all you have to do is do that math every time you move it around. And so, believe it or not, I actually asked Runtime to do that. And they made a utility inside of RAID Reconstructor that does it. They added an exclusive OR routine. Of course, they didn't tell anybody how to use it. That was awesome. But they did add it. I said, like, because they're doing entropy, and I'm like, well, you know, there is a way to tell, and it's exclusive OR. Anyway, we'll talk about that. But here's the real problem. Second drive goes. This one's dead. Which one do you need to recover?
Second one. The third one that died.
Yes, you need to recover the last one that died. Yeah, the most recent failure. Because this one was in sync the day that it died. But now it's way out of sync. This is 6 months later. So this one's the one. How do you know which drive? You get a box, and you got 4 drives in the box, and maybe you get lucky. Maybe they put 0, 1, 2, 3, 4. Who knows? But
You don't know which one failed.
you don't know which one it is. Nope. Because who knew? Which one? The fired IT guy. He's the guy who knew. And maybe the janitor. The janitor actually might know, because the janitor, he's mopping the floor and he goes, oh, there's a red blinky light. That wasn't there last week. He might actually know. So I've asked before, he actually does. So it's like, oh yeah, it started blinking like 6 months ago. Oh, that one started blinking yesterday. That's cool. I like blinky lights. So you have to recover the last drive that failed. That's it. That's the one you got to recover. None of the others are going to be useful. So that's what we're going to do, is we're going to focus on those. Now the rest of the time, you're getting the mystery box. It's an exclusive OR routine. So A exclusive OR would be equals C. So that's what happens in a 3-drive array. But here's your options for the things that you don't have. You don't know your disk order. You don't know your slice size. And then there's an option for what's called the arrangements. And we're going to talk about those in a minute. Windows uses stupid names. Forward, backward, dynamic. But Linux has real names. And so luckily our studio uses the real names. Runtime Reconstructor, or RAID Reconstructor, uses the stupid Windows names, and they're just dumb. And then you don't know about your fragmentation, and that might cause a problem. So, blah, blah, blah. So we're going to do it. That's all the words I used to back that up. So, this is the arrangements. This is what the Linux world primarily uses for names for all of the content. So I want you to see, remember the puzzle picture I was talking about where I could slide the squares around and I could figure out what the arrangements were? Look at these arrangements. So if you were looking at a picture that came off of these drives, and it came from this, so this is drive 0, drive 1, drive 2, blah, blah, blah. But this is now, think of it as a picture. This is that square. I'm looking at that segment. Let's say it's 64K, and I'm looking at that segment. This top row is going to be right if you have the right disk order. If all of your drives, if you put them all back together and you're not dependent upon the parity slice, and you have those drives in the right order, this top row, the picture will actually be in order. Now the second row, the picture will be in order until you get to approximately where parity is, obviously, unless you're dependent upon that and you're using an application that calculates that. But I want you to look at the next one. This one's called left asynchronous. The next one is called left synchronous. You see the top row? It is the same. The layout is the same between those two. 1, 2, 3. See that? That's that slice that across the top that would be right. Now the second row is not right. If you look, they're different. 4, 5, 6, and then rotates to 7. And remember there was one of the pictures that had like a little blemish that was over here on the right later on in the lower row. It was in one of the earlier pictures I showed. It was a blue stripe across the top and had a blemish right here. Yeah. So that's where this parity, it hit that spot in that parity. So the row was actually right, then it corrected itself and it was parity. And then the next rows were wrong. Okay? And if you're looking at this, so if you look at the other rows, they will cycle back through. So once you get to the bottom of the cycle, they actually cycle back too. So on 4 drives, they'll actually cycle back through every 4th time. So your slice will repeat over and over. So you'll have a stripe that's good. The problem will be is that as the data shifts and the JPEG calculations are doing something with that, you might not have the colors right. So you might still see the stripe correct, but the color won't be right because it now has the wrong color tone for the stuff prior to it. Does that make sense? So when you're looking at this and you go back and forth between them, you'll actually see that those two have variations that will cause that problem. Now, here's the other thing. The next two. There's one called write asynchronous, and there's one called write synchronous. So all those things that you were scared of, with all those variations, there are 4 of these variations, but you will not see write synchronous or write asynchronous in any of the controllers. I have never seen them in any of the controllers unless they were a 5E or a 5EE. So if somebody said I have a compact RAID array, or I have a HP, or I have a IBM RAID controller. Now you're looking at 5E and EE, and those are write arrays. And so they are not going to be in any of the NAS boxes, and they are not going to be in any of the low-end controllers. They're not in High Point, they're not in Adaptec, they're not in AMI. They're not in any of the low-end controllers that are like sub $1,000. So you won't see them at all. So I can almost completely say, if somebody did not say I had perk, no, perks are not even those. Perks are actually still synchronous, right, left synchronous, there's no rights. So at least from that standpoint, if you're not talking about IBM or any of those others, they're going to be left.
So we're down to 2 options.
So you're going to take 2 options right off the table. So some of the things you know right now. You know which one's the first drive? MBR. You know it's only going to be 2 options for the 2, either left or right. There's no rights. You're only going to have 2 options for lefts. And then you have options for your slice size. So when you're looking at your options for your slice size, you could have an 8K all the way up to a 2000K. So at this point in time, you could have small slice up to a very large slice. This is not common for you to have these many options in almost all of the controllers. A lot of the low-end controllers, not every one, like a perk has some crazy options that you can still do, but if you know what your controller is, if you even knew that, you could look up what your options are. So if you knew that you have a High Point controller or something like that, or a Adaptec controller, then you know that you may be limited to 32K to 512. So you could eliminate those right away. I will tell you, almost every one of them that some IT guy did not mess with is probably 64K. Almost always. Now the IT guy gets his, I'm setting it up. Oh, it would be cool if it was 8K. Well, then you're going to have to play with that. If you have a Lossy, it's going to be 64, 128, 256, or 512. It could be any of those. If you have pretty much anything else, most of the others are going to be 64 or 128. So if you stick with 64 as the base and you start with 64, then you can figure it out as you go through between those things. So almost always, unless it says it's Lossy, then you have your choices are 64K, 128K, and then in the Lossys you have 256 and 512 as 2 more options for the size. So this is almost always. Then you have left. So you have left asynchronous and left synchronous. So you have those 2 options. And you know which one is your first disk with your MBR. Right? There are other things you can do to figure out the pictures and how big a picture is going to be. So remember we talked about manual carving. You have to know FFD8. You could actually carve out a picture manually and you can figure out how big a picture is. So when I told you before, it was if I carved the picture out and it was wrong, it will tell me the inappropriate size. You can't look at the size in the file system. So as an example, I took a picture and I cut it out. Let's say it was corrupt on the drive or I have my slice sizes wrong. And I took that picture and I saved it. You see the size of the dimensions that the metadata says this picture is? That is not 8K. That's not an 8K picture. Right? How big would that be?
10 meg or something.
10 megapixel. Exactly right. So I know you kind of maybe guessed a little bit. Is that about right? No? Yes?
Yeah.
2.5, 4.
Oh wait, you looked at the pictures.
What?
2.5 times 4 is about, so.
Yeah, so you can do that and you can try to guess, or you have another option. You go to the web and you go find a calculator for the size, the physical dimensions, and then based on the only thing that changes is what happens in between the JPEG with its compression. Now most of the cameras are using somewhere like between 90 and 95 or something around there. We're probably closer to about a 2 meg picture. So that's probably what we're looking at for that size of a picture. Does that make sense? So I'm looking at approximately 2 megs if I enter in what those dimensions are, knowing the camera, knowing the things. That's what I'm going to base my decisions on. So I throw some drives in the array and I try to figure out what this is. I've now fixed the drives. I fixed what I needed to do. We're still imaging a drive. We're still trying to fix what we're going to put together. Now, I'm going to say this is 2 megs. And so like you guys looked earlier and you glanced at it and said, oh, 64K, that's what's happening here too. So the question is, so if you break this down and you divide by 2 every time, if you look at the top slice, you can see that the second row is wrong and it started to shift. But this top row is right, even though there's not really much color up there along the way. And then it looped through again. Remember I said every cycle it's going to loop through? When it loops through, watch this. See how big? See this slice is bigger than this slice? That's right. In many cases that slice is bigger. It's twice the size. Understand? Look at the layouts. I don't know if it actually has a layout right here. I have to look. So remember I told you it would loop through depending on the drives? Actually, since we have 4 drives, there would only be 5 stripes before it would loop through in many cases. So what will happen is it will loop back through. It'll go through this, and this stripe will be right, and then this stripe will be right, and then that stripe will be butt up against the other stripe that's right in the same order. So you have 2 stripes that will be back to back, which accounts for the wider area.
And it repeats itself.
And then it repeats itself. And so when you're looking at this picture,
Larger picture.
huh?
It goes to a larger picture.
Yeah. So when you start to see this, now you start seeing color changes and shifts because JPEG's processing this stuff differently for its dithering algorithm stuff. But do all of the items belong in this picture? Are all of these, huh? Are they all part of this picture?
No, there's one there on top.
No, it's all shifted. But see, like this is the top of her head. And then it shifts, and then you've got another shift, and then you've got the finger and the hand and all this. So do I have discs in the right order?
Yeah.
Yes, I do. I have the discs in the right order because they're actually slices like this. And I have the discs in the right order. How big is my slice size? 64K, right? So we can tell it looks like 64K. So the only other option that's left in this picture that would be wrong is...
So go back, so what do you have in that picture at 512? One more? So what are you showing me with 512? Well, that's where it would be,
I'm dividing in space. I'm dividing in, so I said, if this is 2 megs, then this is 1 meg, then this is 512, then this is 256, then this is 164. I'm just dividing everything in 2, visually. That's really what I'm doing, based on the amount of size. So I'm just trying to calculate what that slice might be if it was that wide. You know, if it was a 4 meg picture, well then I'm at 128. And if it's an 8 meg picture, then, and so on and so on. But you don't know what that size of the picture is without trying to calculate what that is, because if it's wrong, like this is actually going to give me the true representation of the file, but it doesn't always. Like when we're wrong, we need to know what the size of that picture is so we can figure out what our slice size is. And so I would use the EXIF information from the picture, if I can, to prove that. So I'm trying to use that data. So what would actually be wrong in this case is whatever the choice is for the 2 items that I actually chose for left synchronous or left asynchronous are wrong. And all you do is change that one. So once you know you've got your order and you've got those things, instead of just keep going, now I still make a list, I still write it down on paper and I still say I tried this, 1, 2, 3, 64K in this orientation. And I still like mark them off until I've checked them off. But I would only have like 6 variations or something that I could possibly do at this point to figure out if it was better or worse. And so once I actually figured out which one it was, and I switched from one of the asynchronous modes, then I actually would get the picture right.
Now that's if it was originally 5 drives. It wasn't 4 drives.
Well, this is actually 3.
3. Oh, okay.
This one's actually 3 drives. But yes, if it was, the pictures, so in these cases if there was 3, so depending on those, these are pictures from our studio. These are pictures from a website. So these are what Linux calls them. And then so these are pictures from our studio in the orientation. So we're going to do it. They're on the computer. Okay? So what I want you to do is, and it is typed up, but let's switch to the computer. There's 2 methods we want to use here. RAID Reconstructor and RStudios. I want to show you RAID Reconstructor first because RAID Reconstructor is supposed to do all this automatically. Now UFS Explorer probably would do this all automatically and figure it out automatically. But there are a lot of better tools than there used to be. But I want to show you RAID Reconstructor and what it's supposed to do. So start up RAID Reconstructor.
Images on the same place?
What's that? What did you say?
Images are in the same location.
Yeah, but they're in the RAID 5 directory. So if you look there, you will find, and you can put them in any order, but if you look and you click on the double dots, the first thing is you're going to have to say, we're doing a RAID 5, and I know I have 3 drives. I've repaired all 3 drives. I have all 3 running. We can do it with 2, but I want to show you 3. It doesn't matter whether we do it or 2 or not. We just have a blank space. So RAID 5 and 3 drives. That's what I've sent you in the mail. And then you click on the double dots and you go load all the images. And so when you load the images, they're going to be in the same directory, but there's one called RAID 5 version 2. And you need to load the ones that are just DD. So we're going to do one at a time in each position, each one of the DD images. Everybody okay? Everybody done it? Okay. Once you have all 3 of them in their position, if you did not have one of the disks, if you repaired 2 of them and you had 2 of them and you didn't have one of them, it's missing disk, you just leave it blank. You just leave one of them blank and it will be the missing disk, so you don't fill it in. And it will treat it as a missing disk. So you have to have at least 2 of them. This one happens to have all 3, and so we can try all those variations later. But now, you're not supposed to have to know anything down here. The theory is that the tool is supposed to figure it out for you. Now, Windows RAID arrays, they use these stupid names, backwards, forwards, blah, blah, blah. Who cares? Just let it. The whole point of RAID Reconstructor is it tries to figure it out by entropy and guess correctly. So just say open drives. There is a button now that says step 2, analyze. Click analyze. I don't care what it says here. Click next. This is something that they added on in hopes that they could try to do like a sample of the drive. Just click next. So I never pay any attention to any of those things. I just let them go because they never work. Okay? So everybody should be at this screen now. So as many people said, RAID Reconstructor you've not had a lot of luck with it. It doesn't work a lot. I'll show you when it doesn't work and how we can fix it. So the thing is, they should have checked all these boxes for us. They didn't. But you should check all those boxes because we don't know what the slice size is. So you'll notice it's 16 sectors at 8K up to 128. Now I will tell you right now, if you have a Lossy drive and you see the words Lossy, add 256 and 512 because you would have to do that. If you had to add 256, it's actually 512 sectors, and then 512 is actually 1024 because it's times 2, right? So if you had a Lossy drive, you should add those. A Lossy.
You have to make it the custom block size?
Yes, you would have to if you had a Lossy. Because it's Lossy if we can get our data back. So you would have to add the 256 and the 512 because they have both variations. Now, for some reason, the standard for Lossy seems to be 256. Lately, the ones I've been getting are 256. Is that what you're getting? You guys getting?
Yeah.
256 lately. I don't know why. It's a dumb way to do it. All right. So after you've checked these things, just say next. That's all you need to do. So this is how they were supposed to run. And you see it failed. And when you click this button, huh?
90% of it not kept.
Yes. What does that button say when you click it? It says click here for more. It says, please send us more money and we will do this RAID probe thingy and we will give you, your answer, tell you what the configuration is for another $300 or whatever it is. Blah, blah, blah. If you do that RAID probe thing, they charge you. Right? So this is BS. I've complained about it, but they don't listen. All right, so make the thing as big as you can see. Like, drag all these things so you can see what all your stuff is. So make it as big as you can see, like that. Everybody see that? Here's what they don't tell you. They're doing an entropy test, and they use a key system for their entropy test, and they made this crap up. I don't know what numbers they used or how they decided, but they go in increments of 1, 2, 4, 8 or something like that. When they have a high number, when the number is greater than 6 or something like that, they say success. We know which the number is. When they don't, then they just rate wherever they are at this point in time. So you'll see in this column right here, it says OS:4. That's their entropy count. The higher the number, the better you are. So if it didn't match anything when they did an entropy test, we have nothing. The entropy did not work. It failed. On the times that it actually worked and did something, that says OS:4 in this case. And that number goes higher as it increments. So when it finally gets high, it will actually say success, and it will turn green.
So a lot of probe more seconds.
It won't really work. There are certain instances with entropy that their calculation can't figure out what the derivative is for the area around it. You can change these numbers all day long and it won't get any higher. It will never figure out what this RAID array is. And this is a real RAID array. This is a hardware RAID array, not a software RAID array. I actually took 8 gig drives, I made a hardware RAID array, and then I broke it and I made these images. So this is a real hardware RAID array. But if you knew that OS:something and the higher the number, then you could examine the column and you could say, what are my possible choices? How many choices do I have in this entire list from top to bottom? Because it's actually a longer list, right? There's a scroll bar here. But from top to bottom, how many possible choices do I have to examine? 2. There's only 2 choices. So let's assume you knew nothing except the order of the drives. You win right now.
Sorry, I don't understand. How is it going to?
There's only 2 choices. See OS:4?
Yeah.
That's their entropy counter.
Oh, sorry, there's 2 versions of that. Excuse me, I didn't see that.
Yeah, there's only 2, right? So there's only 2 choices. And one of them is 1, 2, and 3. And the other one is 2, 1, and 3. So if you did know the disk order, and the guy was at least lucky enough to write a number on your disk of, I pulled this one out first and I pulled this one out second, you already know and you win. But even if you didn't know, you only have 2 choices here that will work. So you can pick either choice you want and check it and see if it works. So let me show you how to do that. Like I'm just...
Sorry. I'm only seeing one result. I'm only seeing one version of it.
Did you check all the...
If we put 512 and there's only one, it dumps that in the scale.
What's that?
If we had 512, the custom one, and there's only one.
Oh yeah, if you added other stuff to it, then it like changes the...
Ah, okay. I see. That's what I did. That's all right then.
Yeah, because it won't match mine at that point.
Okay, sorry.
And then just, then do it again.
I just wanted to be on the same page as you. Just
Right.
Okay, that's very good. I never saw that before.
Right. Okay.
Thank you.
So if you pick one of these, I'm going to just pick the first one here. And I'm going to say finish. Now when it says finish, it'll now go to the next step, which is step 3. And this is, you have 3 choices. You can save a virtual image. So a virtual image is what I use the most. And the reason I use a virtual image is I can mix and match drives. I can use physical drives and I can use image drives. I don't image the good ones most of the time. Most of the time, I do not image the good ones. I fix the bad ones and then I image those. And I have DD images. And then if I have 16 drives in a row, I'm hooking them up through any method I can. USB, physical drives, RAID or controller, whatever I can do to connect them to the machine.
Why is that every side of it?
Yeah, every side. So if I got 14 drives in a RAID 0 array, I've just got to keep throwing those things in there. So I physically will continue to add those things till I have them. So virtual images do not require me to make an image, and they do not require me to spit out a physical disk. Virtual image makes a physical, just a standard physical XML file pointing to all the data. So I just saved this in the root of the drive, and if you make the path wrong, it won't do it right. So if you type c:\/ file name .vim, it has to be .vim, virtual image file, virtual image, however it is. So make a file name c:\/ .vim, and the file name .vim, and then you hit. Everybody okay with that idea? Like I actually name my files after my test. Like I know this was RAID 5, I chose 64, and I'm doing 1, 2, and 3 in the order. So the previous choice that I made, I make my file name according to that. So that I always save one according to what I did. And then you hit copy, and when you hit copy, it'll save the file. I'm overwriting it. And if you do view, you'll see what it is. The view shows you it's an XML file, and it just shows you your layout, and shows you where they are, and shows you blah, blah, blah. So that's what the virtual image file is.
Where's the view?
There's after you hit copy, save, there's one that says view. So you hit copy, you say yes, you see this? You can now try to mount blah, 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 or you can scan it. So you can hit view, and you can look at it. And it's just going to be a text file on the root of the drive.
How do you know that the RAID starts at 0 seconds?
So certain drives, now RAID 0 almost never has like an indent into the drive, but like maybe a per controller and a couple of the others might have them. So you'll have to look for the partition segment and where it starts, and almost always I can figure out from where the partition segment starts how many sectors I am into the drive, and it will be the same all the way across all the drives. So once you know, like on a per controller, if it's 128K, and you can also sometimes Google it and say, oh, I've got a per controller, I've got some other thing, how far am I? Otherwise, you open up a hex editor and you go scan for the beginning of your partition segment for the NTFS string. And then you can figure out from there to the beginning of the drive how many K you have.
And go down until I don't see the 0.
You search for the NTFS and you search for that string. And then you'll actually know how far you are indented into the drive at that point in time. So you will fit that for all the way across. But if you know what your controller is and you Google it, they'll tell you what the segments or what that size is. And those are the things that UFS Explorer is doing automatically for you. They're figuring out where that sector is and where that location is. And I'll show you in runtime here how that actually is done, because there's a way to do that too. Anyway, so that's what the XML file looks at. Now, after you've done this, you'll see that step 4 is highlighted. Now let me tell you about RAID or runtime software stuff. We know that if we're looking at NTFS, which we don't know right now, right? You don't know what my RAID array is. Do you know what's NTFS? You have no idea what I've done. It could be a Linux RAID array. You don't know what I did. So we can't look at it in NTFS if we don't know it's NTFS. If we do, we might get something that doesn't work. The one that they have that's the most versatile is Captain Nemo. Captain Nemo does Novell partitions, Windows partitions, and Linux partitions. But it does not do Mac. They do not have an HFS program yet. So you have your biggest chance of it working with Captain Nemo. So if you click on Captain Nemo, it will now pass your virtual file to Captain Nemo, and it will open it with your virtual file and your images. This is now my RAID array reassembled. Now, what you want to do is, and this is going to take hunt and peck, you would actually have to go look for a picture and see if the picture worked. So you could go down and you could say, is this right? Does this look right? It's under, there are some pictures under administrator, and then I think I put them under pictures or my documents and pictures, or there, my documents. If you go into my documents, there's folders that have pictures in it. And so if you just go find one and click on it, and it opens up, then you can tell if it's good or bad. So RAID Reconstructor did work, even though it told you it didn't and failed. So it is possible to do it. Now, this is, and what I'm also looking at is how big the picture is. This picture is a 3 meg picture. What is the likelihood of a 3 meg picture not being right? 0, right? It's completely 0. A 3 meg picture, if I did not get the RAID array configured correctly, it will not work. Okay?
Come on. Same one.
So if you picked the wrong one, and then you tried to go into Captain EO and open it up like this, it wouldn't have shown the directory structure.
It will show a directory structure, but it may also be munged up. It won't look right.
Okay.
You will be able to actually tell. You can do that, and you can take a step back and do that other one. And you will see that like certain things will happen. Like for instance, the administrator folder will be empty. And some other folder may not, because the file records are now not in order. So if you had it wrong, you will also see directory structure changes that will not match. But it will show you one. It will show you something. It just won't be right. We're going to see that in a minute. Everybody okay? Is it working? You guys good over there? What's up?
When you saved at the end, when you saved the last one, you didn't do the right order.
Yeah, and click. Yeah. Now check all those. Next. And then I picked the first one, but it's the one I'm on. But if you want to pick the second one, you'll see it's wrong. Yeah, the second one is wrong, and that is true. It'd be fine if it was wrong. And say okay, and then you can click Captain Emo, and then you'll be on the right configuration.
That's why I got
Right. If you have the wrong configuration, you probably got some sort of structure, but it was screwed up, wasn't it? Yeah. Now you can go into Documents and Settings, Administrator, and open up a picture under the My Documents folder, and then you can see that it's right and it actually works. And
Can you get that image? Can you use that? Present that to our studio?
you cannot present that to RStudio. RStudio has its own method, but you can present it or use it in UFS Explorer. So UFS Explorer, they have a module that you can use this with, so you can use the virtual image. Now, there's a different configuration for RStudio, and we're going to do RStudio manually because this is doing some automation for you, and so it's still not like the pocket calculator versus doing it with a pencil. So I'm going to show you the manual way. So now, one other thing. So, one other thing I'm going to tell you about, now let's enclose, if you just go back to the configuration, we don't need Captain Nemo open and everything, you can see it works, you can right click, save all the files. But I want to show you one thing that's not obvious at all inside of, you've probably looked at RAID Reconstructor many times. Have you looked on the tools menu? Yes, because it looked like it didn't work. But let me show you something that's amazing. The tools menu. See under the tools menu? Look at one of your tests. If you had them right, as I told you before, A plus B equals C. If we have it right, we should be able to do an exclusive OR test. They just never told anybody how this works. You know what else that you didn't notice so far? They did not tell you which drive was the first drive. Even though they put them in the wrong order in the second choice, if you knew which drive had the MBR on it, wouldn't you know which drive is the first drive? Why the hell did they not tell us that? It's there. It is there, but they don't have any indicator for that. There is an indicator for it in their program. They just don't tell you that there. So I would like for you to run the exclusive OR test. Click exclusive OR. And then you get this window. You see this? And you have a button that says start.
Yeah.
Click start.
Got a big green thing.
What does it say green is at the bottom?
Yes.
Pass. If you have them wrong, it will be fail. It will be red. When it doesn't know what they are at all and it fails completely, it will be ambiguous and it will be white. But I want you to see something that happens that you don't even notice right away. Now at the bottom right now, when I click on it, it's going through these number of sectors. It's actually calculating the exclusive OR for all of these sectors. So it's calculating all of these, and all of them pass. This is a chunk, this is a chunk, this is a chunk, this is a chunk. This is thousands of sectors. It passed. These passed. And they're green. It knew it's right with an exclusive OR test. You see this little box over here on the side that looks really crappy? It has no scroll bar or anything like that. Click in that box and hit the home key or control home. Control home. Look at that. It knows the partition table. It knows which drive is first. It just didn't bother to tell us that in the other screen.
I changed the order and I still got a green box.
Well, no, it's because all the drives are there and it's comparing them. It's actually doing this automatically in this process. It's not telling you the order, but it's comparing the exclusive OR patterns to make sure that they're correct. It figures out the order on its own.
I switched the order, Randy.
I know what you're saying. The tool actually does it for you. It is figuring that out. It's not, all it's doing is doing that exclusive OR calculation, and it is figuring out that on its own. In order for you to cause it to fail on this array, you're actually going to have to change the drives. You're going to have to throw a dummy drives in there.
All it's telling me is that I have the correct drives.
It is an exclusive OR pattern for these in this order. It is doing this automatically for you. It is calculating these in these exclusive OR.
So the top line is telling you that disk 1 is your one with the NTFS boot ring.
Yes.
Right? So in other words, if you would image disk 1 second, and it was disk 2, not 1, you would see disk DD, RAID 5-2.
Yes.
.DD, that would come up there in the top?
Yes. Yes, if the MBR was on the second disk, it will tell you which one is the first one.
I renamed your files RAID 1 drive to 2. It'll tell me drive 2 is first.
Yes.
If you're missing one, does it work the same way, or
It will actually figure out that there's at least enough for the parity to be able to be calculated, so it will do that. So it actually has to be actually wrong. We'd actually have to not have the content in this case. So it is trying to figure them out and do an exclusive OR test. So you can see it when you have completely wrong stuff in there. It'll completely be red, or it'll be ambiguous and won't show up. But my point is that there actually is some rudimentary tests here. It's not that we still don't get to do any work, but it will at least tell us that it's actually doing a calculation and it's figured this out. So, and if you have all the correct drives in there, it does this on its own without our consent, basically. It'll try to figure it out and tell us, but they don't give us the answer. So we have to actually physically go look at it.
if the failed driver you have contained the master boot record, will it still work?
Well, the parity, once they're in the right order with a missing disk, it will work. It'll actually work. So just to give you an idea, I'm gonna close these drives, and here's disk 1, which actually has the actual information on it, and I'm gonna make it blank. And so if I open drives and I do the analysis, and of course this is probably when demos fail.
Is that the one with the actual MBR?
Yeah, that's what he did.
That's what?
Is that the one with the MBR?
All right. But see this? See, this one has a missing disk. Their missing disk is missing disk 1, but it knows that disk 1 was the one with the MBR in the entropy test. This will actually work. It's missing a disk and I only have 2 disks. It will work. If I click this button, I do the exact same thing. Copy, yes, okay, view. It will actually work with a missing disk. And it will figure it out.
Because there's only a 3-drive array, right?
In this case, 3-drive array is correct.
So the parity of life is still becoming a big.
As long as one drive is missing, it can still figure out at least the basics of the entropy test, even if you have one missing disk. So in RAID 5, you have to have 2 to have the data, and it's recalculating the parity for the remaining drive, for the remaining sectors, for the remaining content. So it is doing this. And again, it doesn't work perfect every time, but with some struggle and with some knowledge that at least that was the layout, you can actually try to figure it out and make more advances. But there is still one thing, which is RStudios, which is to do it manually. So, alright, let's go do RStudio real quick, just so everybody can get an idea here. Let's close everything. Close everything. Alright. Okay. Alright, quitting half a day, yeah. Must be nice. Relaxing, kicking back. Alright, open RStudio. RStudio is the ugliest interface ever, especially doing RAID arrays. Anybody done a RAID array in RStudio?
Yes, 1 million drives and 1 million partitions.
Yes. Alright, so what we want to do first is we want to load our images into RStudio. So this is where your list of the disks are, this is where the work is going to be done, this is your log file. So I'll show you how to create this RAID array. They make you create a virtual RAID array. So go to Drive, Open Image. And you can open all 3 of the RAID ones just by clicking on Control. So you can actually open each RAID file by clicking on the DD and holding down Control. So you go DD, 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 and open those 3. Everybody okay?
Yeah.
Alright. Which one's disk 1?
The one that says NTFS on it.
How about that? Woohoo! Now, here's your hard thing. Do not select the partition, select the drive. If you select the partition, you're throwing it off by 63 or 64 sectors, actually. You'll be 64s into the disk, huh?
Software rating sometimes wants
What does?
software rating.
Oh, it's software array, yeah. But you want to select your partition after you've combined your disks, not before you combined them. So that's the first thing. Now, so we have 3, and we know which one right away is disk 1 just because of that. We don't know the other 2. But,
Sorry, I just missed you there. What did you say? What did you discover so far?
so right away, you see when you put all the disks into the image, you know which one has the MBR on it.
Okay, of course.
Because it tells you,
Fix it up already. Yeah.
right? So it's already picking it up. Now, we just have to make sure we do not select the partition, because the partition would be 64 sectors into the drive from 0 to 63. And that would throw these off, and then the 2 images combined would not be correct, right? So let's just say I had a really big RAID array, and I had to do this manually, and I had to figure this out, which I have had to do with like target files for movie studios and things like that, and in time. So what you have to do inside of RStudio is you have to create a virtual RAID array, and then populate it with this data. So under Create, you will see a Create Virtual Block RAID. Click that. Create Virtual Block RAID. That's how you make a RAID 5 array. So when you click this, you will now get an additional image, and it will say Virtual Volumes. And then you will say Virtual Block RAID 1. Everybody see that? Now the easiest way to populate this, they do have a drag and drop interface, but I don't like it. The white box that's over here, if you right click, it will show you all your devices. Make sure you select your images. Now here's the thing, RStudios does not do it automatically for you. You will manually have to figure out what the order is. So it's not like RAID Reconstructor where they calculate it and try to give you an automatic idea. You have to manually select it. So you know your first drive is disk 1. It says it right here. Do not select the partition, select the DD image. And when you do, it will remove it from the list. Right? So don't do the partition, do the drive. Then, add the second one. Now, if you did not know what order they are, this is where our examination is going to come in. And so, and I'll tell you that our students will do it wrong by default. So you will know right away it will be wrong, and you'll have to figure it out. So if you select number 2 and then number 3. Now, the other thing you want to do, if everybody's here at this spot, the next thing you want to do is this. We know this is RAID 5. You've been told this is a RAID 5 array. This is not a RAID 0. So this is a RAID 5. So select RAID 5. Now, there's one other thing. Does everybody see a button that says apply changes immediately? This used to be a bug. It used to be off the screen. Is it off the screen or can you see it? Check that box, please. Anything that you change, it will not take place if you do not have this button checked. So check that button so that every time you make a change, it does that change immediately. Now you can see in the list what our choices are. We have RAID 5. We're currently at 64K. And then here you have your 4 choices that I talked about earlier, which would be your left standard synchronous, left asynchronous, your right synchronous, and right asynchronous. So the default one that you'd want to start with would be 64K, which I've already told you is the majority of most of these RAID arrays. The second thing is I would leave it at the default, which is left synchronous. Because I know it's going to only be one of those 2 anyway. It's not going to be a right synchronous in this case because I did not tell you it was an IBM controller or anything like that. So then you're going to have an expensive drive and an expensive tape drive. So at this point in time, if I had a big RAID array, I need to know as quick as I can, is this right? So I want to scan for JPEGs. I don't want to waste all day processing and scanning all of these things for all these variations to see if it's right or wrong. I just want to see pictures and I want to see them fast. Does that make sense? So we did do scanning earlier. So see the partition that we now have right here in the virtual block RAID on the left hand side? It has created a virtual partition 1. You see that? So I want to scan for JPEGs only. Do that. Do you guys remember how to do that? Right click.
How far should I scan?
Until you have around 200 documents of our requested type. So turn off all the ones you don't need if you want it to be faster. What's that?
I turn off the window.
Oh, well then you won't know.
Right.
So change your known file types. You've got to clear all, add graphics back, and add just JPEGs. Because if this was a giant array, it would take a long time. And I know it's not a giant array, so it'll go fairly quickly. But if it was, the whole point is to do this fast. So you do just JPEGs, you leave detail scan on, and you click scan. And now you'll see, as it's going through the array, you see down here in the bottom it starts calculating all the content as it's going through it. So you see it's doing specific documents. Those are the ones we're asking it to carve. So it's done 114 a document, so we've asked it to carve. And down here it shows you where it's going, blah blah blah.
How accurate is the time on this? Is it accurate?
Well, I don't know for sure how accurate it is because I don't wait.
You can stop it though after a few minutes. once you-
Exactly. Perfect. As soon as you know that you've got enough documents to look at, we don't need to wait for the end of the array. If we had 50 terabyte here, it would take us forever. We only need a handful of these. I know people who do this. I swear to God, this happens every time. Somebody sets up a RAID array, they start the scan program thinking that, I will come back when it's done, and then we'll see if we win. If we don't, then we'll change all the settings. So at the end, they're like waiting a week. And at the end of the week, then they say, oh, this didn't work. I got to try again. If you only do JPEGs, What's that?
I was going to say amateurs, I shouldn't use that term.
Exactly.
You get out of them.
That's the point, right?
Get out of them, you won't spend time.
So once you get enough, I mean, I'm way enough. I got 2,000, and I'm still nowhere near the end of the drive. This still might take a while. I mean, imagine this is only a 16 gig RAID array. This is only 16 gig RAID array, and if I wait even for this one, it may take me a while. So as soon as you know that you have enough documents, you hit stop. Are you sure you want to stop? Yes, I do. Now you have extra files found. Please look at those pictures and tell me if it's right.
No.
It is not correct. But when you look at the pictures, let's just say I jump in there, I pick some pictures. Now you do need to take a sample. Do not trust only a handful of files. You need to check different things of different sizes. The bigger the size, the better you'll probably be, but some of them might not be viewable if they are wrong. So if you pick one and you click on it, it may crash, corrupt, whatever. Like this one, like obviously it's wrong. As soon as you know you're wrong, you are wrong. Because if it's right, it's either right, or if it's wrong, then there's some corruption or something else is happening. But you can't trust a small sample. Like small files, depending on boundary and compression and things like that, like I'm sorting by size, small files may actually be okay. Like when I go to click on small files, that one looks fine. If I go down here and click on some 5K files and whatever. Does that make sense? Everybody okay? You understand why these small files are okay?
Yeah.
That one's obviously not. So I'm going to drop down here to some big files like I was at a few minutes ago. So I'm down here. I'm going to pick a big file. Now look at this picture. Do I have all of my slices? Do I have all my drives? Are all my drives here?
Yes.
Yes, all my drives are here. Do I have all my drives in the right order?
Yeah.
Yes. And you know that right away because the stripe at the top is right. So if those are actually segments, and this is one segment, and this is two segments, and this is three segments, then I actually have, it's actually going to be right. You're actually going to see that component as you're looking at it. The other thing is, does all the content belong to this picture? It actually is part of this picture, right? So I'm pretty close to actually being right. What's my slice size for this picture, probably?
How big is the picture?
I think it was, I mean, I have to look at the XF information to know for sure, but I think it's like 3 megs or something. According to this, it's like 2.5 megs or so. So it's, huh? Now, I'd have to actually look at my XF information. It will probably be right at this time, but if it was a screwed up RAID array and I did not have them in the right order, this file size would be wrong. It will actually physically be wrong. So I'd have to extract the XF information and I'd have to look at it. Now, you can look at it in hex. So let's say I'm here. You'll notice I can right click and I can say view. And RStudios has its own hex tool in here. And I can cut out a chunk of this, save it to my desktop, and then see what my XF information says. Or calculate it from the type of camera, blah, blah, blah. Right? So everybody understand what I mean? So in the picture there is XF information, so I can highlight, like we did earlier, carving, manually carving, and I can just take a big chunk of this supposedly right thing, and I can save this. And so I can then export this. I think there's actually a save routine somewhere in here. Huh? Save to binary file. Hit that. Then I'm going to go to my desktop. I'm going to save. This is actually a JPEG, right? So I'm going to do test1 or test2.jpg. And I save this. And if I get a big enough chunk and I look at the desktop now, I'll actually be able to see whether or not I've got some chunk of a picture or whatever else. See, I started getting it across the top. You can start to see it. I didn't get a big enough chunk for it to be something I can tell very clearly, but you can see it's the top of the tree, right? See it? If I save more, I'll get more.
Wouldn't it be easier to test it using smaller pictures? That way you can figure out the exact size of rate.
Say it again?
Wouldn't it be easier to test the rate using smaller pictures rather than these large pictures that you don't have to figure out the JPEG information, the size of picture information, and everything else?
Well, I I generally feel like I can do better with a bigger picture than I do a smaller picture. The smaller pictures aren't going to be as accurate because compression, fragmentation, boundaries. Bigger pictures, you know right away you're wrong when you're like in excess of like 2 megs or something like that. You're way beyond slice size, right? So now the other thing that you need is you need something that actually looks at XF information to tell you whether or not I can see anything here. So there's a number of free tools or something out there. But if I look at this, I believe my XF information, if they haven't changed it in this version, if I go to my desktop, I think I'm administrator, my desktop, where am I? Shoot, there it is, thank you. See? So Directory Opus is doing this function for me. I could download another tool or whatever. But see, if you look at Directory Opus, it parsed the data from the EXIF information, or you can use an EXIF viewer or whatever. And I can take this and calculate this and type it in to a calculator and figure out what it is. And according to this, this should be about a little bit bigger than a 2 meg picture. Right? Everybody good? Even though it currently is not, it currently is 14K. It certainly isn't a 14K file. Right? Everybody okay? Now, so I'm back in our studios, and I'm looking at this picture. So, I know I have my drives, all my drives, and I know they're in order, and I know it's a 2 meg picture. So how big is my slice size? Looking at this picture. Huh? It's what?
It's like 8 into 2 megs. It's 8 sections.
Yeah, I mean, yeah, there is.
Yeah.
But from what I'm looking at least again from, huh?
How do you tell?
256.
I'm looking physically like this is 2 megs, and then half would be 1 meg, and then half would be, and then half would be somewhere right around here, and then, but no, look. So this is a stripe that's wrong. So even though this might, maybe you think it looks like it from there, but see this is wrong, right? And then
Go to
that.
64.
We're on 64.
All right, we are on 64, so my slice size is 64. So what's my only other thing that's left? No, what's my only other, I only have 3 options I can change, right?
Left the same thing with the AC.
Try that. See if any of the other options work.
Let me go back and look.
Oh, you can actually go right back to the picture.
You can, but I will tell you sometimes that's buggy. If you really want to be sure, you should probably clear the settings and do it again, but it does go back, but every once in a while it's buggy and kind of freaks out. So you can go back, get rid of this, and then I'm back to where I was on my virtual RAID. And then the only other thing I can do is change my options for this. Now, if you've discovered that now it works, your next job is in the directory above this one, there's a RAID 0. Shouldn't take you but 5 minutes to figure out RAID 0 now. RAID 0 is so easy. Do those 2 in this application. Do a RAID 0 on your own. There is RAID 0 files above this directory. Do RAID 0, get it done. On the hard drive, there is now, if you go look, oops, there is RAID 0 files up from here. So if you go look in that data recovery directory, there is RAID 0, and there are 2 image files in RAID 0. Reassemble it. They are assembling a RAID 0. In the directory above those, there's a RAID 0 directory with 2 drives in a RAID 0 array. Use RStudios to reassemble RAID 0 on your own. RAID 0 becomes amazingly simple by comparison. And that's a real RAID 0 array from a hardware RAID array. It's not full of a lot of information, but it's still a RAID 0. It's actually a Adaptec controller. Once you're done, that's it. That's what I got for today.
Now, what about offset?
So offsets are going to be any time that you've got something that's at the beginning that's indent. That's why I said.
That's the same thing as what RAID reconstructor means first sector.
Yep.
Then offset.
Exactly the same thing.
Perfect.
All you gotta do is find the beginning of your partition and you'll know where that sector is, and that's it. But like some of them are standard, like I think perk is 128. Can we do it in the morning?
Huh?
We can do it in the morning. Do it in the morning. Tomorrow, because tomorrow we have labs and stuff too, so we can work on it tomorrow.
So if somebody sent you 2 drives,
Yeah.
in my case, I've got one working drive, one not working drive, RAID 0 array.
Right?
Image the good drive that you know works, and then use that to pull for the other drive?
Yes, I do that. I do that a lot in RAID arrays where I have like, 16 drives in a RAID array and I don't want to have to go like shopping parts. That is exactly what I do is I completely image that drive and then I can use that for parts if they are exact matches. That's correct.
Using a TK image to dump a DD to the disk?
I do dump a DD to the disk. That's all I do is just make sure that I get a good copy of it and verify it before I take the first drive apart, before I take it apart.
Right, but if you can get that, then you can plot it out, get the other one, try to get that to work, and then take the 2 DDs,
Yes.
together here, and then recover the data.
That's correct. And in your case with Promise Controller,
Yeah.
yes, then that's no problem.
Okay.
Right.
What doesn't this emulate besides the higher end ones? Like it'll do an Adaptec, you said. It'll do a Promise. It'll do the motherboard ones.
AMI, Adaptec, Promise. It just doesn't do 5E and 5EE. But UFS Explorer does.
Okay.
Like if I took 2 DD images and somebody told me, oh, well, this, or 3 of them or 5 of them, bye. If I took those and somebody said, oh, well, this came from a compact, then I can throw that in UFS Explorer and use the same thing. It's just DD images still. You just need a different program to process those. Or if it's from a Buffalo Terra Station, I cannot do it with at least this does not support XFS. So this will not do a Buffalo Terra Station.
Okay.
I have to use UFS Explorer to do that.
Okay. But if you're using regular, like, whatever it is, XP, that had the spanning drives, it's no problem.
Yep, no problem. Do it all the time.
Alright. I feel a whole lot better.
Well, like I said, there's a couple of other ways to do it, which are actually look at it in hex and then break the segments down and then try to figure out from the space of the segments. And that's what the class from Hoffman, because Hoffman in the Netherlands, they have a class where they actually have, and they have a script they wrote. You know what I'm talking about, Hoffman? Hoffman's an investigation company. They're kind of like a PI firm or whatever you want to call it in the Netherlands. And they actually have like other operations in other countries too. But they teach a class on how to actually take the segments and actually, look for the segments and the break in the segment and the buffer in the segment from one segment to another and then calculate the space between the buffers to figure out if it's 32K or 64K. And our studios wrote a similar white paper on it.
Yeah, I read that.
Yeah, and it's
That's actually how we do it. We use like
Right.
sheets and put in, just follow the patterns.
yeah, but it takes a lot of time, doesn't it?
And I actually,
Right,
the background is, I have sheets of the last
right,
but even still, it's still a couple hours.
right. In this case, usually in under 45 minutes, I can look at a picture and I can figure out, well, am I close or I'm not close?
I know, that's very nicely split.
Yeah.
Really cool images. Maybe like a sort of, that's a very easy, you give that to a student.
Right. Yeah. Yeah, I like this method most of the time. Like I said, it's not perfect every time, but the majority of the time I can do it. And I've done this for like movie studios and other stuff like that before, where they've done target files and the machine died in the process of writing these things out from an SGI machine and things like that. And I've done hundreds at this point that are very similar.
You said they mentioned about the offset. Do you worry about that now?
Most of the time on most of the lower end RAID arrays, no. But from time to time, you know, like some of those RAID arrays that write a segment at the beginning that has a counter that says IM drive 1, IM drive 2, IM drive 3, like a PERT controller does, you have to set the offset to get past that. So if you have a PERT controller, then you have to, and it's probably 128, it's probably 128K. And so you just set your segments for 128K, and that's your offset. And then the drive will show up.
Why I mentioned it, because these 3 terabyte RAIDs,
Yeah?
I think starts pretty far.
Okay.
Like don't start close to that, like, I mean, obviously not like an terabyte.
Right.
Don't start like close to 0, it's like a couple of thousand.
Okay. We'll look at it tomorrow and try to figure it out there in labs or something.
I understand what you're saying there. I mean, you just said where do you put it into our studio?
Our studio has it on the right hand side. See that where it says offset and sectors?
Good one.
Take
Take care.
If I put it in sectors and put it in the water, it would go.
Lads, tomorrow.
Yeah, but how do you know what it is? Yeah,
That?
yeah,
Well, how do I know what it is?
yeah.
Well, you know what you're doing in Hex when you go and you look for your segments?
Okay.
You go down for your partition structure and you find the beginning of your MBR in your partition structure. The count from there back,
Okay.
in most cases, is your number.
Yeah.
So if it's like a PERT controller, you'll see it at like 128K into the drive. But you, like I said, you can also, if you just Google your controller, if you know what it is, then there will be a document somewhere that will tell you. Like you can actually find it in many cases that people have done it. But if I want to look at it in Hex, I can actually just highlight from the segment from the MBR
Yes.
to the beginning of the drive, save it, and it'll say 64K or 128K.
Yeah.
So I just highlight the segment that I want. Just like I just did there when I was doing the picture. Like this says that it's 14K. So if I had just highlighted this segment from beginning of the MBR back to the beginning of the first drive, if I find the MBR, because I have to find whatever the beginning of my partition structure is.
Yes.
So I've got to look at my drives until I find the NTFS signature, and then go back to the MBR, and then go back from there. So I just highlight from there to the beginning of the drive and save it. And if it's 64K, because it should be one of those boundaries. It should not be some arbitrary weird thing. It should be 64, 128, or 256, or, you know, in some cases there are some that have like a, well, like configuration files. Like sometimes like Lossy, right, makes a segment for their Linux configuration files, and they write just like a 200 meg partition at the beginning and store the data there, and then they offset the second drive to that amount.
Yes, that's right, I've noticed.